An intelligent energy network, or smart grid, is an electricity network that intelligently integrates the actions of the users connected to it, both classical generators as well as consumers, and consumers that are producing themselves, so-called producers, in a way to efficiently integrate sustainable, economic, and secure electricity supply. So in such an intelligent energy network, we have both the control and information and communication infrastructure, as well as the electrical applications. As we see in many business systems, there's a lot of digitization ongoing. Digitization of processes, of businesses. There's lots of communication bandwidth available. There's a standardization towards TCP/IP for exchange of information. There are embedded sensors everywhere. There's the miniaturization of processing. There is cloud storage. There's the Internet of Things. And also all these type of trends, they play a role in the energy system. If we look into the energy system, we see smart thermostats appearing. We see digital meters or smart meters, which are measuring a lot of the consumption data. We see home energy management systems connected to domotic systems. We see ways how the distribution system operator can remotely control the grid. We see ways how to forecast the photovoltaics and the winds. We see automated market clearing and market implementations. We see lots of real-time monitoring, and we see automated demand response applications. So there's a lot of datification ongoing, not only in the general society, but also into the energy system. And this type of datification, this type of digitization and digitalization has lots of advantages. It allows for advanced energy management. It allows, for instance, your smart thermostat to be remotely controlled from your smartphone, even when you're not at home. It allows to increase your comfort. It allows to economize on your energy bill by using a more efficient and energy efficient way to deal with the temperature settings in the home, for instance. Additionally, if we take, for instance, a look towards these open data approaches, lots of data from different sources can be integrated. A very good example is this electricitymap.org, who is really collecting data from all over the world, where we can see the carbon intensity of the electricity production or consumption from the different states within the European context, as well as in the Americas and in parts of Asia and Australia. And you can see the more green the color of your country is, the more climate friendly, the less CO2 emissions are related to the electricity consumption. The darker the color, the more yellowish or brownish, the more CO2 emissions are currently in use for the electricity production or consumption. So the idea or the ideal situation would be a fully green map, and this map is far from green. But thanks to these open data systems, this type of community projects can collect data from all types of different sources. Big data approaches can turn that into usable data for and information for the policymakers. But there's also a downside on all this datafication. For instance, this is a time series from the power usage at a particular home. And it has been taken with a high resolution metering system, as a result of which, if we analyze the data step by step afterwards, we're able to derive a number of things from your personal and private life. For instance, we could see that you are using a washing machine based on the typical profiles that we get from that data. We can see that you have been using your oven and that you've been drinking some coffee in between, all based on the individual appliance characterization. And if we even go a little bit further into the details, we can even derive the kind of settings of your washing machine, whether you were doing the washing of the lingerie or whether you were doing just a cotton wash. So there's a lot of things related to the privacy when we're using this data. And what is privacy? Well, privacy has been defined on many different levels. If we look, for instance, to the European Convention on Human Rights, Article 8 is really focusing on the right to have a private and family life, and that this needs to be respected. Within the European context, since 2016, we've got the General Data Protection Regulation, which is basically putting forward within the whole of Europe, within all of the member states, a kind of unified way to deal with privacy. And every member state, for instance in Belgium, we've got the Belgian Privacy Commission, there is a specific committee and a specific implementation from which you are able to get allowance to use personal data, and you need to ask for that allowance before setting up databases. Additional requirements means or imply that you have to ask permission from the individual customers if you want to use their personal data. And if we translate this to the energy system, if we take the example of a smart meter, for instance, if the only goal of a smart meter is to be able to provide a monthly electricity bill, there is no need to record every 15 minutes of data, because that is way too much revealing of your private information. Another example, if you make a contract with your supplier for an electricity connection, why would your supplier need to know your gender or your age? This is really not relevant if you want to have an electricity connection. They just need to know whether you're 18 plus or not, and if you're able to make this type of contracts on your own. So we need to do a lot of things in order to make, for instance, this whole smart grid more privacy friendly and taking into account all the confidentiality purposes. As an example, we did a study for the Belgian Federal Office of Economy and Energy, taking a look at to which extent smart meters need to be considered if we want to take the viewpoint of protecting the final customer. And of course, the first requirement in order to protect the customer is that we are dealing with the data in a very dependable and secure way, so that we are assuring the CIA qualities, the confidentiality, the integrity, and the availability requirements, for instance, of the ICT and processing infrastructure that is used to collect and to use that data. That requires a very robust ICT infrastructure. And that the privacy is handled conform this General Data Protection Regulation, which I just talked about some slides ago. But if we look further towards the customer protection perspective, if we have, for instance, a smart meter that is remotely controllable, it means that if you are not paying your bill, that the distribution system operator or the supplier could be able to disconnect yourself remotely. And this is also something that we do not want. There are some social rights which, for instance, allow you to have always access to a dimmed electricity connection, for instance, assuming 6 amps at 230 volts, which is about the way that you're able to either cook or heat a little bit of the building so that you're not fully in the cold and the dark during the winter. So we need to have this type of regulations in place in order to protect the customer, because smart meters are providing new possibilities to remotely control devices. Additionally, protecting the customer means that this customer needs to be able to check locally on the smart meter whether the bill that he is getting from the supplier is the correct one. So the metrological function of a smart meter, able to collect data on how much electricity you have been using, should be checkable by the end consumer. Finally, what we learned from that study is that a lot of the legislative framework is not ready for the smart grid yet. Both at the regional level, at the federal level, at the European level, lots of things need to be adapted to be working with these new type of devices and with the datification of the energy system. If we have this datification of the energy system, we can also see that these devices are all connected to each other. And interconnected devices also open up the way towards the dark side. Let's take the example which was in the news in the end of 2016, where there was the Black Energy malware attack, which was putting part of Ukraine into the dark. Or if we look into the dark side ourselves, you can easily find websites, just as kadahacker.com or the German Computer Chaos Club, where you find all types of tools to go into the system and to try to break its cybersecurity perspective. So there is some curse and there is some blessing related to datafication, but we can make this balance going towards more blessing and less of a curse. If we take into account from the beginning of the design of the smart grid these different aspects. The cybersecurity aspect, we need not a single layer to protect our system. We need a defense in depth with multiple levels. We need to guarantee our CIA properties, confidentiality, integrity, and availability. We need to be GDPR compliant. We need to follow the regulations, of course. And we need to take into account by design the privacy approaches. And there are a number of techniques to do that. We're not going into the details of those, but there are ways to keep the data local without having to send everything towards the central agents. And we have to rely on the protection of the customer. And for that, there needs to be a lot of regulation to be changed in order to get there. In this way, we can make the datafication of the energy system, which is very much needed in order to get a smart grid, more of a blessing than of a curse.